Okay, so as we move into transformations, we're just going to do a review of transformations using some notes that I've used in the past, and then we'll look at what the text provides and make sure that we've covered everything. But talking about transformations, corresponding sides and angles. So as we talk about transformations, it's really thinking about moving a image or a figure from one location to the other. So again, here we have like a trapezoid EFGH is congruent to trapezoid QRSP. These two trapezoids are congruent, but they have been somehow moved around, and just thinking about the corresponding sides are a pair of sides that have the same relative positions in two congruent figures. So EF is congruent to QR, and we look here is congruent to QR. That would be the corresponding sides. As you can see, it's the same length. It has the little hash mark or tick mark, and just being able to look at that, we can see what corresponds to what by looking either at the name or at the image. And then corresponding angles are a pair of angles that have the same relative position in two congruent figures. So corresponding angles, F is in between angle E and G and has one arc, and here R is in between Q and S and it has one arc, so these are corresponding angles. If I look in the name, F is the second letter, R is the second letter, so that's how we can tell too that they are corresponding. So just being able to think of those definitions and understanding what do corresponding sides and corresponding angles mean, it's going to deal with the location of them. Transformations. A transformation is a one-to-one mapping of all points of one figure to another figure in a plane. So all points. So if I were to label this triangle A, B, C, then this would be A prime, B prime, C prime. Just using that as an example. They're just saying that B maps to B prime, C maps to C prime, and A maps to A prime. So that's what they're saying, that I can find the mapping just like in the previous example up here. Technically, E would map to Q. So just that's a bad example. Let's not even think about that because they're in different orientations. But just understand that the pre-image points in the pre-image map exactly to a point in the pre-image maps exactly to one point in the image. So that's what they're saying, that we should be able to see this kind of connection in some way, shape, or form, a transformation of the congruent item. Here, in example number 1, consider figure WXYZ, WXYZ as we named it. Complete the statements. Well, what things correspond to what? Here, point W corresponds with, thinking about it, it's got one arc, should correspond to point C. So then we would end up doing this. We'd say, hey, it looks like it probably goes around like this. Then angle ZWX corresponds to, let's see here, ZWX. That should correspond then to BCD. So that should correspond to angle with BCD. In the segment XZ, XY right here. XY right here should correspond to DA right there. So that should correspond to DA. So just being able to see which ones match up. And of course we can see some of this stuff in we have 4 tick marks, we have 4 tick marks, we have 3 arcs, we have 3 arcs. So, just being able to understand and associate those. So that's introduction here to basics. As we talk about the rigid transformations, a rigid transformation or an isometry is a transformation that preserves. So a rigid transformation preserves the size, length, shape, lines, and angle measurements of the figure. Okay, and then the pre-image and the image are congruent. Okay, So that's big detail. So as we look at this, I've gone and filled out some of this information, but hopefully you can see that this first image is a reflection. Things that we can see, I can see that some characteristics that we will identify, that my points, it looks like these are my points that are that correspond to one another. So this would be, we'll just say D prime. If this is E, this would be E prime. If this is F, this would be F prime. Some things that we can see, it sort of looks like we have, if we connect our corresponding points in a reflection, it looks like I have a bunch of parallel lines that are forming from the different corresponding points. All points of the pre-image are reflected across a line of reflection to become the image. So this is my line of reflection. Think of a mirror, and as it reflects, you reflect back and forth, and when you look in a mirror, you look to see appear to be the same distance. You could think of a pair of shoes. If I have a horrible pair of shoes here, look more like kidney beans, but they are a reflection of each other. Your left and right shoe are a reflection. So just think about how those appear, and the points. Think in some of the characteristics of a reflection. D here was the closest point to the line of reflection. D prime is still the closest point to the line of reflection. So these things start to have characteristics that we can identify. Transformation is also one of our rigid a translation is one of our rigid transformations, sometimes referred to as a slide. And really, in this transformation, this is all, sort of like the previous example on the other page. My points correspond, and it looks like I could possibly just slide something across the table or across the board, and this would be D, E, F, and then this would be D prime, E prime, and F prime. So all the points in the pre-image will move the same distance and direction to produce the image. So here too, we also see these parallel lines forming, but if you'll notice the same distance, that means this, and this are all the same length. Where in a line of reflection, or in our reflection, all of my parallel lines were technically different lengths. So similar characteristics, but slightly different. A rotation, now rotation or turn, all the points in the pre-image are rotated around the center of rotation. So here, the distance, and if we look at this image, it looks like if we had D, E, F, this would be D prime, E prime, F prime. And looking at my lines of rotation, by point of rotation, if I connect D to my center of rotation, and I have E prime, and I see that angle that's formed, and I could say that, hey, that looks to be about 120 degrees. If I did that, and I connected all my corresponding points, D to D prime, that seems to be the same distance as that. And then if I, again, did it with F, you can see that all the points are being rotated the same amount of degrees. So we find that the corresponding points are equidistant from that center of rotation. Okay, so just looking at some of the transformations and the characteristics. So here, example number 2, what type of transformation maps QRS to Q prime, R prime, S prime? To look at this, if we connect the points, connect the corresponding points, S and S prime, R and R prime, Q and Q prime, those three lines do not form a parallel. There's nothing parallel there. So it really, that eliminates our reflection and translation. So if I remove those, now what happens is the orientation has changed. So I could tell you that from experience that, my center of rotation is about there. Thinking about Q to Q, S to S. So that is about my center of rotation. So what type of transformation? It's a rotation. Even by process of elimination, it wasn't a reflection or a translation because there was no parallel lines. So we know that that's a rotation. And let's see the transformation. What transformation is here in example number 3. Again, if we connect our associated points, corresponding points, sorry, A to A prime, B to B prime, and C to C prime, looks like we have 3 parallel lines that appear to be the same length. So there is my translation, okay, or slide. So just being able to recognize that. That's what we're doing here in this section, is recognizing the basic transformations, rigid transformations. Non-rigid, we will actually cover this non-rigid transformations more in the future. This is going to be when we cover similarity. Okay, we're going to talk about dilation and expansion and enlarging and reducing things. So what you know here is just that the sides all change by the same factor. If you can see, these two sides are 2, their corresponding sides here are 4, so it looks like we enlarged by 2. If I look at the other corresponding sides, these are 3, and their corresponding sides are 6, so they also enlarge by a factor of 2. We will go over that in detail later on, but you can just see that it's not rigid. It didn't stay the same, and we're focused on rigid right now. Transformation notation, and I've spoken to this as we go, but prime notation is used to indicate that a figure has undergone a transformation. So here as ABC has been translated. So, we've gone from here to here, right? Just understanding that triangle ABC corresponds to triangle A prime, B prime, C prime, because that's my new triangle, A prime, B prime, C prime. Point A corresponds to point A prime. CB corresponds to C prime, B prime. And then angle ABC corresponds to angle A prime, B prime, C prime. So this is indicating my pre-image, and then my new image will have your prime indications. That's how we sort of know. We start here. This is my pre-image, and this is my new image. Okay. Mapping notation, this is sort of a mapping notation. It says a transformation maps a figure onto its image. An arrow is used to indicate the mapping. So C maps to C prime. That's what that is indicating. So if I wanted to say up here, that would be triangle ABC maps to triangle A prime, B prime, C prime. Okay. That's what they're saying, and then they spell it out for you right here. C maps to C prime. Point C maps to point C prime. ABC maps to A prime, B prime, C prime. So just understanding what they're asking and how we indicate those. Here on module 4, or example number 4, type of transformation. Again, very similar before, that we have not maintained orientation, right? RS is the top side over here, but it is not the top side over here. So my orientation has changed. If I draw those two lines, nothing is connected. I'm sorry, it's connected. Nothing is parallel. So by virtue of that, I would say that we appear to have, again, a rotation. Which transformation here shows a line of reflection? Okay, again, or shows a reflection. Again, connect your points here on number 5. F to F prime, E to E prime, D to D prime. Okay, not parallel. E to E prime, F to F prime, D to D prime. Look to be parallel, not all the same side. There's probably a line of reflection in there, but E to E prime, F to F prime, D to D prime. These are all the same length. So this is my translation, my reflection, and probably going to be a rotation. So just being able to recognize and see those. Which type of transformation maps this trapezoid? Hey, this is going to be a dilation. Don't worry about it. We're going to cover that later. And let's see here. And don't worry about this one. It is also covering dilation. So the basic rigid transformations, understanding some of those characteristics. In our text, they've gone over the same information they have, looking at their vocabulary, analyze features and identify the types of rigid transformations, calculate the coordinates of the vertices of image given coordinates on the pre-images. We'll talk about the coordinate plane here. Transformation, what are they? Pre-image, that's where we start. Image, that's our new image. Rigid transformations, maintain this corresponding sides and angles. It's a congruent figure. Reflection, we have a line of reflection, translation, rotation, line of reflection, center of rotation. We'll talk about translation vector, but there you go, or angle of rotation. So we've covered these, just looking at them, making sure we didn't. But again, there's my reflection. Seems to be very similar to the items that we were going over. And we'll talk more about this in class, of course. Looking here, identify the type of rigid transformation shown in the photograph, reflection, translation, or rotation. It looks like we have a line of reflection right there. So it would be a reflection, whereas if we moved a checker from here to here, we didn't change the shape or size, we just sort of slid it across the board, so that gives us a translation. All right, so identifying transformations on the coordinate plane. Again, we can probably do some of those, and that's what they've done here. This one, difficult to see. We will practice long before we get into that. But here you can see that they have created 4 lines. It sort of looks like a trap prism. Looks like a prism now. So this is my translation. And this is actually a reflection here, but we will get some more practice with that moving forward before we tackle something this challenging on color, black and white, paper. So don't worry about that. If I needed to test this, though, for translation, I could use the distance formula. So just think of those things, using some skills that we've had all along. Here, looks like we have rotation again. You can see that we have this rotation. We have this rotation. So this angle is the same as this angle. Just practice seeing it. Reflections. Now, we're going to cover this more in detail with reflections, but if you think about it, reflections, if I reflect over the x-axis, right here, this is my x-axis. If I reflect either upward or downward, in this case we're going downward, the x value didn't change because we just went from a positive y value to a negative y value. So think of that if the only thing I have to change is the y value, because the x value remained the same. See, because as we reflected over the x-axis, I was on x is 7 and I was 3 positive, so if I reflected I would be 3 negative. So that's your mapping, right? And we'll go over some of this. And then think about if I reflected over the y-axis. All I'm doing is, my y value remained the same. As I come over here, I just went from a positive x. I come over here, I go the same distance to a negative x. So I went from 2 to a negative 2. But my 3 remained the same. So, right, this is a 3, this is a negative 2, this is a 2. This is a negative, a 4, and this is a negative 4. So just seeing the changes that we have made on the x and y axis. Very logical, very logical. We just have to sort of practice with it. So again, just thinking about it, they've drawn my image in here, and again, we're getting a little bit ahead of ourselves when we talk about these reflections, but they've mapped ABC in there, and it says determine the coordinates of the vertices of the image after reflection over the x-axis. Simple put, I'm just going to do this. I'm going to say, hey, if I'm reflecting over the x-axis, right, I'm reflecting over this line right here. B is 2 away, so B prime is going to be 2 away. A is 2 away, so A prime is going to be 2 away. C is 5 away from my line of reflection, so I will come up here to 5 away from my line of reflection. And you know, honestly, with practice we'll get better at it, but there's my reflected image. Okay, and we'll go through a lot of these practices, but just understand, so that's how we would have done that. And they give you a good example, and there it is. So just sort of, we could have used our mapping. Obviously, we could have used our mapping. So if x, y, it tells us maps to x negative y, so the x's remain the same, and the y becomes negative. So we went from 2 to -2. In this case, the 2 would remain, the x remains the same, the x remains the same, and then we change the sign of the y value, so that becomes a +2. That becomes a +5, and we could have mapped it that way. It just depends on how you practice and how you think about it. Okay, and that's, and then the same thing for your y-axis. If we were to reflect over the y-axis, I'm 1, 2 away from the y-axis, so I need to go 2 away from the y-axis. 4 away from the y-axis, right? C, 1, 2, 3, 4, 1, 2, 3, 4. A is 1, 2, 3 away from our line of reflection, so there's A prime. There you go. I was able to, given a piece of graph paper, map it a lot easier than I was to sometimes do the math to it. But again, my x value becomes the opposite sign, so I would have -3. A 2 would become a -2, and a 4 would become a -4, and those are going to be my points for mapping, or for graphing. So there you go. That's just some touching on basic transformations. We're going to go into much more detail in class, of course, but just getting our feet wet and understanding what a rigid transformation is.